Hello everyone, and welcome to another mini Sky Tonight. So here we are, halfway through the month of August, and I wanted to show you folks some of the constellations and planets and things that you can see this time of year before school starts. So that way you and your family can go out and explore the nighttime sky while the temperatures are starting to get cooler and before your children have to get back into school and are busy with their homework and things like that. So in the evening time, roughly around about 8:45, 9 o'clock, just after the sun sets, if you look towards the southeast, you'll see these two bright stars. They're not stars at all. In fact, they are the planets Jupiter and Saturn. Now, in the planetarium program Stellarium, which is what I'm using right now, one of the unique things that you can do is if you left click on an object that you see, over to the left of the screen, you'll see a ton of information. So you get to see some information that you may never get to use, but some information which could be quite helpful or useful. But one of the things I wanted to show you folks is that you can be able to zoom in on these objects. So the way to do that, you first click on the object to where you see like these little red lines that kind of go around in a circle and go in and out around the object. So once you've done that, you simply take your mouse and drag towards the bottom menu. Once it pops up, you'll see these four arrows that kind of point towards the center. This means to center the object in the center of your screen. So let's do that. So boom, Jupiter is now in the center of my screen. And now let's zoom in on the object. And to zoom in on the object, we're going to use our scroll wheel. The reason being why we have to center it on the center of the screen is because if you use the scroll wheel without centering the object, the scroll wheel will center in on the center of your screen. So it's important to put the planet or the object that you want to zoom in on at the center of the screen. And let's stop right here. And if you want to take away the information, just simply right click on your mouse and it'll just show you the view. I wanted to stop here because this is the typical view that you normally see through a pair of binoculars or a small telescope. Jupiter, and you can see the beautiful bands of Jupiter if you look relatively close on a clear moonless night, and you'll see these kind of four bright stars that are to the left and to the right of the planet. Those are the Galilean moons because they were first discovered by Galileo Galilei. These are the four prominent moons around Jupiter. Now, Jupiter has over 60 moons and counting because Jupiter's gravity is so immense that it just picks up random objects here and there and they fall into orbit. But these four moons, astronomers suspect that these were naturally formed alongside with Jupiter. But one of the things I wanted to also show you here is that you can also not only zoom in on planets, but zoom in on moons. So let's click on this interesting moon right here called Io. Io is a fun planet. It's one of my personal favorites because of what it looks like. So let's zoom in on it. So let's center it on the screen and using our scroll wheel, zoom in. Pretty unique features, right? I like to call it the cheese pizza moon because it kind of looks like a bit of an overburnt cheese pizza almost because it's highly volcanic. The surface of Io is riddled with volcanoes. And the reason being is because poor Io is in a gravitational tug of war with Jupiter. So this poor moon is quite literally being pulled from the inside out. Crazy. Another fascinating moon around Jupiter is the moon known as Europa. Astronomers are highly interested in this moon is because they believe that there's a liquid ocean underneath the surface of Europa. Now, Europa's surface is different from other surfaces of planets and moons and stuff. It's because the surface of Europa is completely covered in ice. It's a gigantic ice ball moon. But this moon has a shifting ice crust, so to say, because the liquid ocean underneath the surface shifts and it causes the ice on top to crack. And material flows in through the crack, and as soon as it hits the coldness of space, it freezes. So the cracks change over the course of time. But astronomers are interested in it because the cracks are not just clear colored or white colored like normal ice water, but they're brown in color, which indicates possibly organic material. And so as you can see here, we're zoomed in on it, and you see those cracks and those fine lines are the cracks in the ice. And they're kind of filled with this brown material, which indicates organic materials. So could there be a liquid ocean underneath the surface of this moon with a thriving biome going on underneath the surface? We don't know. Hopefully, in sometime in the future, we'll be able to send a spacecraft to discover this. Another feature I wanted to show you folks is something I always think is really unique, is that you get to see the planet rotate over the course of time. But you got to set it up just right. So first you got to do is center the planet into the center of your screen, zoom in on it, but we got to do a couple more unique different things as well. First of all, we got to take it off of our atmosphere because we're looking at it through our atmosphere. So we're going to do that. The next thing we're going to do is we're going to take off the horizon so all of a sudden it doesn't completely disappear. Now we're going to fast forward time to allow it to rotate. So let's fast forward time. Now Jupiter rotates incredibly fast for its size. For every 10 hours on Earth, Jupiter rotates once. That means one day on Jupiter is 10 hours on Earth. So for every 2 days on Jupiter, Earth experiences 1 day, which is crazy. But I wanted to rotate the planet to show you this feature, that big, huge red circle in the middle. That big red circle is known as the Great Red Spot. It is a huge tropical storm on Jupiter. Now, when you get a tropical storm, it's created when a high pressure zone and a low pressure zone intermix here on Earth. The same thing goes with Jupiter. The low bands are your high pressure zone and your high bands are your low pressure zones. I know it seems kind of backwards. So the brown bands are your high pressure and your white bands are your low pressure, and they're intermixing, creating this big, huge tropical storm that is going on Jupiter. And it's existed for thousands of years. So imagine having a huge kind of hurricane going on here on Earth that has stuck in the same spot and has yet to relent. It's that crazy. And the reason being why Jupiter has something like this, it has to deal with its fast rotation. We have a unique kind of jet stream because our Earth rotates once every 24 hours. Since Jupiter rotates every 10 hours, instead of having the curlicue clouds or the unique kind of jet stream that we have, it's straight bands. So hence why you see the bands on Jupiter. And since it rotates so fast, you get to see these kind of tropical storms or these little pocket storms that exist for quite a long time. Now, don't let the size fool you, because it may look tiny compared to the rest of the planet, but this tropical storm, the Great Red Spot, is so big that Mercury, Venus, Earth, and Mars all fit inside of it comfortably. It is a huge storm. Now, that's not to dwarf Jupiter in the slightest, because Jupiter itself is so big that 1,400 Earths could fit inside the planet. Crazy, right? All right, let's zoom out and let's get back to where we were. Let's turn on the atmosphere. Let's turn on the horizon. Let's get back to just shortly after sunset. Beautiful. That's another unique feature that you could do as well. So if you want to kind of like forecast of what things you can see in the early evening sky or even the late evening sky, is if you go over here and drag your mouse to the left, you'll get to see this other pop-up window. And the one that looks like a clock is where you can change the date and time and everything. So if you wanted to say, a week from now, I'm going to be on a vacation with some family. I want to go see what the constellations are like around about that time. You can do that as well. Or some things that I often get requests for in the planetarium is I want to know what constellations were up the time I met my sweetheart or the day I got married or things of that nature. You could do that as well. All right, so those are two planets you can see in the early evening sky facing south-southeast. So what other unique features can we see? Well, we're looking at some of the late summertime constellations, and as the night progresses, we'll start getting into some of the fall time constellations. So let's bring up the constellation lines. So facing directly south, you'll see this J-shaped constellation. For any of you that have seen the Disney movie Moana, you should recognize this constellation because the Polynesians call this constellation Maui's fishhook. So yes, even in the Disney movie Moana, they got a constellation right. Not this second star to the right and straight on until morning business. No, 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 no. They actually got a real constellation. To us, we call it Scorpius the Scorpion. I honestly prefer to call it either the J-shaped constellation or Maui's fishhook because to me it kind of looks more like that than it does a scorpion. But take it what you will. The bright star in the constellation Scorpius lies right here, and it is called Antares. It's a huge supergiant star that is said to explode any time now between now and the next few million years. I know that may seem like, oh, wow, that's the least of my worries, and you kind of are right. But when it comes to things of astronomical proportions, sometimes they take time. I like to call astronomy the science of extremes. We look at the biggest of the bigs to the smallest of the smalls, and sometimes, since we're dealing with extremes, sometimes they take extreme amounts of time. This unique kind of constellation over here, I like to call it the Teapot Constellation because here you got the handle, you got the lid, and you got the spout. It's actually the constellation Sagittarius. But as you can tell, I don't see a half man, half horse out of that. I get to see a teapot. That's the great thing of the unique term called asterism. An asterism is a nickname for a group of stars. So the great thing about asterisms is that you can name an asterism anything. So if you see a constellation and you say, oh, that doesn't look like this to me, it looks like this, okay. You can call that particular constellation whatever you would like. That's the great thing about asterisms, is because they're nicknames. Nonetheless, let's rotate the sky to what it looks like closer towards around about 10 o'clock. So we're going to go over here to date and time, and we're going to look at it, what it looks like roughly around about 10 o'clock at night. So roughly around about 10 o'clock at night, if you go far away from the city lights and look towards Sagittarius, you'll see this kind of fuzzy patch in the sky. That fuzzy patch or that fuzzy cloud is actually the Milky Way Galaxy. Our galaxy seen edge on. And Sagittarius' spout points right towards the center of our galaxy. So that's one of the unique things I always enjoy, is that I sometimes joke around saying, the reason being why Sagittarius is not a half man, half horse, but a teapot is because, well, it points towards the center of our galaxy, which is nothing but a bunch of gas and clouds. So I often view it as the teapot is spewing out steam and it's creating the galaxy. Yeah, now you know why I see a teapot more than anything. Nonetheless, if you look directly up above your heads, you'll see these three bright stars, and they kind of look like they form a triangle. That triangle is famous for navigators because they call it the summer triangle or the navigator's triangle, because they often use these three particular stars for navigation. The top star of the summer triangle is called Vega, and it's a part of the constellation Lyra, the Lyre. L-Y-R-E, not L-I-A-R. It's a harp. Hidden within the constellation Lyra, right between these two stars, is a unique object. So let's zoom in on it, and I'll click on it to show you what I'm talking about. Now you can kind of see why it's important to click on the object in order to be able to zoom in, because it zooms in towards the center of your screen, but not on the object. But since this object is relatively small and so far away, I just simply couldn't click it exactly. But now I can. It's this fuzzy thing. So let's put it in the center and zoom it in. That unique object is called the Ring Nebula. It's a telltale sign of what will happen to our star when our star passes away. What's going on in our star right now is called a process known as nuclear fusion, where lighter elements are being rammed together to produce heavier elements, plus light, heat, and energy, to sum it up for short. So hydrogen is being rammed together to produce helium. Eventually, the sun's going to run out of hydrogen to be able to fuse, so it'll start trying to fuse other elements that are more abundant, and in this case, helium. So it'll start fusing helium, and then it'll start trying to fuse carbon, and then it'll start trying to fuse nitrogen, and then it'll start trying to fuse oxygen, and so on down the line. For stars that are about the size of our sun, it can't keep going further because it doesn't have enough material. So what it'll do is it'll collapse down its core as much as it can to try to conserve energy and try to keep fusing as much as possible. And then it'll just puff out its excess layers that it doesn't need because it's material that's wasted and it can't try to fuse that material. And so if it puffs out its outer shell, it basically creates around the dead core this cosmic ash ball. And in the center is the core of the remnant star. And that's what we see right here. The little tiny white star in the center there is the core remnant of the star. And the ring around it is the puffed out outer layers of the star that once was. Now, as you'll notice over here, there are different designations for this object, but I called it the Ring Nebula. That's its common name, but these other designations are different catalogs that astronomers use. Most of the famous catalogs, like here, like this one in particular, which is famous, is known as the Messier Catalog. It's named after a French astronomer named Charles Messier, who back in the day was trying to find his comet, similar to how Halley found his famous comet. And he came across these unique objects that looked like fuzzy things, but he couldn't quite tell because he had such a limited access to telescopes that he denoted it saying, okay, I've noticed this over a course of time, chances are it's probably not a comet. And even though over the course of time he only found like a couple of comets, his list of this is not a comet list is what became famous. And he came up with roughly about 110 different objects that weren't a comet that astronomers and amateur astronomers today still look for. So this is his 57th object that he found in his list. Okay. Nonetheless, back to the summer triangle, the bottom left star right here is called Deneb, which is a part of the constellation Cygnus, the Swan. It's sometimes also known as the Northern Cross, and I always like Cygnus, the Swan, because it's a unique type of constellation that I kind of can see like a stick figure swan out of this, and it's flying across the Milky Way. Another bright star in the summer triangle is this down right here, which is called Altair, which is a part of the constellation Aquila the Eagle. And you kind of can see an eagle out of this. Just imagine it's like, you know, like the double-winged eagle on the back of a quarter sort of thing. All right, so now let's look towards the east to see some fall time constellations. So let's rotate the sky just a bit to roughly around about 11 o'clock at night to see some of these fall time constellations. So over here towards the east, you see this kind of big great square. This big great square is a part of the constellation Pegasus, the cosmic winged horse. So in the Disney movie Hercules, yeah, this is the cosmic winged horse that was the friend of Hercules. Now, I don't see a cosmic, beautiful winged horse out of this. I mean, I kind of can see a horse. You see like the head and the long neck and his legs, and there's his body, but I don't see the beautiful wings. So I like to refer to it as what the famous cowboy poet Baxter Black called it. He called it the great baseball diamond in the sky. And it kind of makes sense because beginning of the baseball season, it starts to rise in the east. Come World Series time, it's high in the sky. So kind of like a stellar commemoration to the All-American pastime. So I know right now sports has kind of been put on pause because of COVID. So we can still kind of celebrate it in the stars, I guess. But you can see a baseball diamond out of this. So here's home, here's first, here's second, here's third. You got the pitcher here. You got the catcher and the umpire back here. The umpire is just really far back. Here's your shortstop. So you got a ton of unique pictures, but one of my fun jokes I always say, hey, look, it has an all-star outfield. Teehee. I know I'm terrible with dad jokes. Just bear with me. I'm known for my scientific abilities. Nonetheless, if you go from home to first, past the right fielder, past the center fielder, and leave the stadium, you'll see this kind of fuzzy object right here with your unaided eye on a clear moonless night, away from city lights. That fuzzy object is the farthest thing you can see with your unaided eye. Yeah, I was afraid I couldn't do that. There we go. It's a galaxy, our sister galaxy, which is 2.5 million light years away from us. And it's incredibly distant, but yet we're able to see it because it has the power of several billion stars shining light towards us. So let's take a look at our sister galaxy. Beautiful, huh? And this little fuzzy galaxy right here is a dwarf galaxy that is in orbit around the Andromeda Galaxy. Now, I mentioned that this object was 2.5 million light years away from us. Now, in astronomy, we use different types of yardsticks because vastness of space is huge. So instead of putting like tons of zeros at the end of one particular distance, we just use bigger yardsticks. Because 1 light year is roughly about 9 trillion miles. So it's quite a long distance. So for something that's 2.5 million light years, that's really far away. But we're also looking into the past because a light year not only can be seen as a unit of distance, but kind of a unit of time. Because it's taken 2.5 million years for the light to cross the vastness of space to reach us. So that means we're looking at light from the Andromeda Galaxy that is 2.5 million years old. Or another way to think about it, we're looking at the Andromeda Galaxy as it was 2.5 million years ago. So if the Andromeda Galaxy was to disappear off the face of the universe this second, you wouldn't find out for another 2.5 million years. Another fun constellation that you can see this time of year is this W-shaped constellation, which is the constellation Cassiopeia, the Queen. Now, if you've seen the movie Clash of the Titans, for you young kids, get your adults' permission, but for you adults, I recommend checking out the movie Clash of the Titans because this whole area of the sky kind of covers this unique tapestry of a story, which is depicted in the movie Clash of the Titans. Now, back in the ancient times, they didn't have some of the modern conveniences we use today for entertainment at night. They didn't have books, magazines, computers, things of that nature. All they had was a campfire and the stars. And they would tell tales of death, danger, endless love, and place those stories in the stars. And this is one of those stories. So if you see the movie Clash of the Titans, you'll get to see the beautiful story that the Greek and Romans portrayed with these different constellations. And Cassiopeia, the vain queen, is one of those characters. So these are some of the constellations and planets you can see this time of year, including a few deep sky objects. If you have any questions or comments, leave it down in the comments below. Or if you want another topic or something else you would like for me to discuss, leave it down in the comments as well. Also for you parents, if you're looking for some fun activities for your kids to do when they're not busy with their homework to keep them engaged over the weekend, futurereadysa.org is a unique site that provides educational activities that engages with your students, as well as some fun things that you can do together as a family, and allows students to be able to earn badges in order to be able to progress further. And from what I'm told by some of the students, having some of those badges is a sense of self-pride, like they need to have these badges to earn things. So if you're interested in checking them out, futurereadysa.org is where you can go. I personally help with the Astronomy Plus mission, so if you want to go check that out, I would certainly appreciate it as well. And I'll leave a link in the description below. Until next time, stay safe, stay healthy, and as always, never stop learning.